So for today's video, we're going to talk about operations with fractions and examples. Mainly we're going to go over multiplication, division, addition, and subtraction with fractions, and we're going to have a set of examples. I'm going to give you 6 examples for multiplication, 6 examples for division, 6 for addition, and 6 for subtraction. So hopefully this will help you better understand this topic. We'll start off with multiplication. So for multiplication, we're going to have our first example will be 2/5 times 3/7. Our next example will be 4/9 times 3/6. Our next example after that will be 5/8 or 5/8 times 6/25. Then we will have 7/8 times 6/5. We'll have a rather interesting problem after that, which will be 8/9 times 9/8. And then we'll end off on multiplication with 22/34 times 16/26. Okay, so we'll have 6 multiplication problems. We'll start back at the top. If you want to, you can work these through ahead of time, and then you can follow along as we solve them, or you can work them with me as I go. So for the first problem, we have 2/5 times 3/7. And so immediately I see everything is in simplest terms, so I'm just going to multiply the numerator with the numerator, the denominator with the denominator, and I'm going to get 2 times 3 is 6. On the bottom, 5 times 7 is 35. And that is my answer for the first one. For the next one, we have 4/9 times 3/6. There's a couple of things we can do here. One, I notice 4, 6, 3, and 9 actually have common factors between them. Another thing we could do is we could actually multiply the numerators together, the denominators together, and then simplify afterwards. What I'm going to do for this one is I'm going to start off by multiplying the numerators together and the denominators together, and then I'll simplify afterwards. So 4 times 3 is 12. 9 times 6 is 54. And then here I notice both of them are even, and I'm pretty sure there's some other factors here too. So we're going to find the prime factorization of these. We're going to get, on the top, we're going to get 2 times 2 times 3. And on the bottom, that's 9 times 6, I believe. So that's 3 times 3 times 2 times 3. And now we're going to simplify. We're going to, there's 1 3 on top, 1 3 on bottom, 1 2 on top, 1 2 on the bottom. And then we're going to be left with 2/3 times 3. And why am I writing in red? Should not be writing in red for this. We're going to be left with 2/9 as our answer. Okay. On to the next problem. We have 5/8 times 6/25. And I'm actually going to erase this portion. I don't need it for now because we already... Oh, sorry, that was not 2/9. That was... No, actually it is 2/9. Never mind. I'm just going to erase that portion so that way I have a little bit more room. Here, I'm going to do things a different way. I'm going to look at the prime factorization first, and then we'll get our answer. I prefer to do the prime factorization first because it allows me to work with smaller numbers. So on my first fraction, I'm going to have 5 over 2 times 2 times 2. And then 6 becomes 2 times 3. And 25 is 5 times 5. I'm going to see that 1 5 on the top and 1 5 on the bottom can cancel. 1 2 on the top and 1 2 on the bottom can cancel. And now I am left with, what is that? On the top I'm left with 3. On the bottom I have 2 times 2 times 5, which is 20. 3 20ths. And now for this problem, I'm going to rewrite it. I'm running out of a little bit of room, so next time I need to give myself a little bit more room, but it's okay. So for my next problem, we had 7 over 8 times 6 over 5. And so here, I'm going to do the same thing. 7 is a prime number, so I'm just going to leave it as 7. 8 is going to turn into 2 times 2 times 2. Prime factorization of 8 is 2 times 2 times 2. 6 is 2 times 3. And then 5 remains the same. And so now I can simplify 1 2 from the bottom, 1 2 from the top. And now I will be left with my answer being 7 times 3 on the top, which is 21. And then on the bottom, I will be left with 2 times 2 times 5, which is 20. Now in this case, 21 over 20 is an improper fraction. And so therefore, we could also write it as a mixed number. If you want to write it as a mixed number, you will say how many groups of 20 are there in 21. We get 1. And then 1 left over. 1 and 1/20. Both of these are the same answer. It kind of depends on how your class or how your teacher or how your textbook wants the answer to be. Both of them are the same. If they want them in mixed number form, you can write them as 1 and 1/20 or 21 over 20. A good practice to get into is writing both of them at the same time. So 21 over 20 and 1 and 1/20. All right, on to the next problem, which is 8 ninths times 9 eighths. For the astute minds out there, you'll realize that this is actually a trick problem, and that 8 on top, 8 on the bottom, that can cancel out. 9 on top and 9 on the bottom will cancel out with each other, and we're just left with a nice, solid 1. Okay, now on to a big problem. So here, we have 22 over 34 times 16 over 26. Each of those numbers are even, so I know they can at least be simplified. So I'm going to start by writing the prime factorization. I'm going to give myself quite a bit of room here. 22 is 2 times 11. 34 is 2 times 17. 16 that's 8 times 2, so that would be 2 times 2 times 2 times 2. And then 26 is 2 times 13. I know for some of you, you may see, okay, well, there's only one factor of 2. Why would you write the entire prime factorization of 16 when I could just say that 16 is 8 times 2? You can do that. That is a simpler process. Some of your teachers may show you that. Some of your textbooks may show you that. I always learn to do the prime factorization mainly because once you get everything prime factored, you then immediately see what factors you can cancel out. You don't have any other guesswork. You don't have to sit there guessing, is there anything else that I missed? You can just see immediately, all right, here's the numbers I'm working with. And so here, on the top and the bottom here, a 2 cancels out, and on the top and the bottom here, 2 cancels out, and I am left with 11 times 2 times 2 times 2. And then on the bottom, I'm left with 17 times 13. Keep in mind that 2 times 2 times 2 here, this is 8. And so 11 times 8, in this case, would be 88. And now all we have to do is figure out what 17 times 13 is. So 17 times 13, we get 3 times 7 is 1, carry the 2. 3 times 1 is 3, plus the 2 is 5, carry is 0, and now we get 170. Adding this together, we get 221. And so our answer in this case is 88 over, whoops, went a little too fast there. 88 over 221. And since I did the prime factorization, I know that to be in simplest terms, and I wrote an extra 2. How dare I write an extra 2? There we go. Now it's in simplest terms. And there's our answer. Awesome. Okay, so that covers multiplication. Multiplication, I think, is pretty simple. More or less, you just multiply the top and the top numbers together and the denominators together, the numerators and the denominators, and then you simplify. Or you can simplify first and then multiply. Choice is yours. So the next one we'll deal with is division. Now for division, we need to remember the reciprocal. And so for the reciprocal, we have a couple of steps. Division will become multiplication, and then the second fraction gets flipped. So the second fraction is flipped. Okay. Running out of room there. But that's more or less what it is. Okay. So for division, we'll have these examples, and I'm going to give myself a little bit more room. I'm going to have 2/3 divided by 5/6. That'll be the first one. The next one will be 4/5 divided by 16 over 25. The next one after that, I think I'll do it right here, will be 1 2/3 divided by 3/5. And then we'll have a few more examples. The one after that will be 2 3/4 divided by 4 1/3. Then I will have 7/12 divided by 1 2/9. And then for the final example, put it right here, we'll have 3 5/7 divided by 4 9/14, I believe. Yes, 4 9/14. Okay, so I'll go ahead and work my way back up, and then we'll start with the first example. Okay, so for 2/3 divided by 5/6, we need to remember to use the reciprocal first. 2/3 will remain the way it is, and then division will change to multiplication, and the second fraction will get flipped, and we'll have 6/5. Now, here we can realize that 2/3 will remain the same, and then 6 can be simplified to 2 times 3 over 5, and we are then left with the 2 3 on the top and the bottom will cancel out, and we are left with 4/5. Okay. Nice. Okay, on to the next example. We will do the same thing. 4/5 will remain the way it is. And then 25, we will turn this to multiplication, and we'll get 25 over 16, which will then become 4/5 for the first fraction. The second fraction will become 5 times 5 over 4 times 4. And we can simplify quite a bit here, and I'll switch back to red. 1 5 will cancel, and 1 4 will cancel. And we will be left with 5 over 4, which can also be 1 and 1/4. Either one works. Okay, next example here. All right, here's where things get a little bit more tricky. I've implemented a mixed fraction for the first fraction here. Sorry, a mixed number for the first fraction. So when you're working with fractions, you need to first change the mixed number to a fraction. So if we remember how to do that, 3 times 1 is 3, and then adding the 2, we will get 5. And so now we will have 5/3. Again, we'll use the reciprocal for the remainder, and we'll get 5/3 times 5/3. And in this case, nothing cancels out, so we are left with 25 over 6. Awesome. Okay, on to the next problem. Here I'm going to do the same thing. We will first need to get these into improper fractions and then take the reciprocal afterwards. So 4 times 2 gets us to 8. Adding the 3 gets us to 11. So for the first fraction, we will have 11 over 4. I'm going to keep it as division right now, so that way we don't get too mixed up. And then for our second fraction here, we'll have 4 times 3, which is 12. And then we will add the 1, which gets us to 13. And so then we will have 13 over 4. Now in this case, oh sorry, not 13 over 4. 13 over 3. Where is my eraser? There's my eraser. 13 over 3. Nice. Now we can take the reciprocal, and we are left with 11/4 as our first fraction, times 3 over 13 as our next fraction. 11 and 13 are both prime. 3 is a prime number. 4 is the only one that has any factors, but since none of the other numbers have factors, we will just multiply straight across. And we are left with 11 times 3 is 33. And 4 times 13 is 52. And that is our answer. Okay, on to the next problem. We have 7/12 divided by 1 2/9. So this one is actually a little bit simpler. We'll first start by taking care of the improper fraction. Sorry, taking care of the mixed number. I keep getting that mixed up. 9 times 1 is 9. Adding the 2, we'll get to 11. So this new fraction is now 11 over 9. Now when we take the reciprocal, we'll be left with... Actually, I'm going to erase this. It's going to get a little messy. Let's just do it like I did before. So I'll have 7 over 12. I'm going to keep the division sign for right now, and I'll have divided by 11 over 9. Now when we take the reciprocal, we have 7 over 12 times 9 over 11. Now here, I know that 12 is 2 times 2 times 3. I know that 3 is 3 times 3. So I can cancel out one of these, one of the 3's, and I am left with 7 times 3 is 21 over 4 times 11 is 44. Okay. On to the last problem. So, for this last problem, we have two mixed numbers, and so now we need to convert them to fractions first, and then take the reciprocal. So I'll start with 7 times 3 gets us to 21. Adding the 5 gets me to a 26. So I have 26 on the top over 7. I'm going to keep it as division right now. I'm going back up to my previous number. 4 and 9/14 now. 4 times 14 is 56, if I remember right, plus 9. That will get me to 65. So then I will have 65 over 14. Now, taking the reciprocal, I'm going to have 26 over 7 times 14 over 65. Now, here, 26 has prime factorization 2 times 13. 7 is prime already, so we're just going to leave it as is. 14 has prime factorization 2 times 7. And this is one key point why I like to use the prime factorization. 65 has prime factorization 5 times 13. And so if you didn't know that, you wouldn't see that the 13 can cancel out. And so now we can cancel out a 13 on the top, a 13 on the bottom, and a 7 on the top and the 7 on the bottom. Again, we can't cancel out the 2's since they're both in the numerator. You can only cancel out numbers if they show up at least once in the top and once in the bottom. And so we will be left with, on the top we'll have 4, and on the bottom we will have 5. And so that whole problem simplifies out to 4/5. Nice. Okay, so for the next set of problems, we're going to be doing addition and subtraction. We'll start with addition. I'm going to give you 6 problems of addition to do. Now, this is going to have a lot of work related to it, so I'm only going to do them one at a time. I think that's going to be best for us. I'll start off with the first ones, which are kind of simple, and then the ones afterwards get quite a bit more challenging. So the first problem we'll work on is 6/9 plus 2/9. Again, we'll be doing addition here. So since they have the same denominator, we can just add them straight across. 6 plus 2 is 8. And that is my answer. The next problem, we have 3/5 plus 1/5. Again, this one is kind of simple. Since they have the same denominator, I keep the 5, and 3 plus 1 is 4. Okay, now let's start to get a bit more challenging. The next problem after this is going to be 10/14 plus 2/3. Okay, so 10/14 plus 2/3, we need to find the lowest common multiple. And so in this case, 14 has factorization of 2 times 7. And 3 is just 3. So in this case, my lowest common multiple, my LCM, I'm going to take the 2 and the 7 from 14, and I'm going to take the 3 from 3. And I will be left with 14 times 3, which is 42. Okay. So now I'm going to rewrite my problem. We have 10/14 plus 2/3. And so now we need to know what number do I multiply 14 by to get to 42, and what number do I multiply 3 by to get to 42? Well, this number is 14 times 3, so then 10 times 3 is 30. And then what number do I multiply 3 by to get to 42? And that's 14. And then 2 times 14 gets me to 28. Okay, so I have 30 over 42 plus 28 over 42. Those are my two new fractions. So 30 over 42 plus 28 over 42. Since they now have the same denominator, I can just add the numerators together, and I'm going to get 58 over 42. Additionally, you can change them to be a mixed number, and you can take out a factor of 42 from the top, and you'll be left with 1 and 16 over 42. And then even then, this could simplify down to 1, and both of them have a 2, and you are left with 8 over 21 if you take a 2 from the 16 and the 42. Technically, all 3 of these answers are correct. However, if you want it in simplest terms, that answer is 1 and 8/21. Also, if you want it as a mixed number. You could also simplify out 58/42, but most times they won't have you do that unless they already want it in a mixed number. Okay, next problem we're going to have is 5/8 plus 3/10. Okay, I need to find my lowest common multiple between 8 and 10. 8 can be represented as 2 times 2 times 2. 10 can be represented as 2 times 2 times 5. And this is actually a very similar problem to what we did in the previous video. In this case, my lowest common multiple, I'm going to take the 3 2's from the 8 and the 1 from the 5 from the 10, and I will be left with 2 times 2 times 2 times 5, which gets us to 40. Okay, so I'm going to rewrite my problem. Actually, I'll keep the 40 right here. So I'm going to rewrite the problem we have, which is 5/8 plus 3/10 and now we just need to know what number do we multiply the two denominators by to get to 40. Okay, this one, what do you multiply 8 by to get to 40? It's 5. So we're going to multiply the top by 5, and we'll have 25. In the other problem, in the other fraction, we'll multiply by 4. And so that means we'll multiply the top by 4, and we will have 12. Okay, so my fraction problem is now 25/40 plus 12/40. 25 plus 12 is 37, and the denominator remains the same. And if you want to check it, 37 is a prime number, and so that is the answer. All right, we have 2 more addition problems to get through, and then we'll move to subtraction. So the next addition problem will be 2 and 5/12 plus 1 and 3/5. Oh, lovely. All right, so first off, in order to find the lowest common multiple, we have to get these to be improper fractions first. So we need to convert them from mixed numbers. So 12 times 2 gets us to be 24. Adding the 5 will get us a 29. So we'll have 29/12. And then in this side, 1 times 5 gets us a 5. Adding the 3 gets us an 8. And so we have 8/5. Now here, we need to find the prime factorization of 12 and 5. So 12 can be written as 2 times 2 times 3. 5 can be written as just 5. And so since they have no numbers in common, my lowest common multiple is all of their factors together. So that is 2 times 2 times 3 times 5. And so if you work out the math, you will get 60. All right, so writing our fractions again as improper fractions, we have 29/12 plus 8. Let me write that one more time. Plus 8 over 5. All right. So now we just have to know what number do we multiply 60 by to get to 12, and what number do we multiply 5 by to get to 12. This one is 5, so we're going to multiply the top by 5. This one is 12, so we're going to multiply this top by 12. 29 times 5. Alright, let's do some math. So, if we haven't already been doing math. 29 times 5. 5 times 9 is 45, so I'm going to write down a 5, carry the 4. 5 times 2 is 10. Adding the 4 back, I'm going to get 145. And similarly, on this problem, I'm going to have, I guess I might as well keep my coloring scheme now. 12 times 8, or 8 times 12, either way works. 8 times 2 is 16, carry the 1, I get 96. All right, so my two fractions now, because I need to rewrite them again, is 145 over 60 plus 96 over 60. Okay, so now we just have to do 145 plus 96. Oh, joy. 140 plus 90, that is 230. 5 plus 6 is 11, so that's 241. And 60 remains the same. Now, if you want to simplify this as a mixed number, you will get 4 and 1/60. And those are your answers. Okay, we have one final addition problem to do, and then we'll move on to subtraction. So we have 3 and 4/7 plus 5 and 3/9. Multiplying 3 and 7 together, I get 21. Adding the 4 together, I get 25 over 7. 5 and 9 together, multiplying that, I get 45. Adding the 3, I get 48. Okay, so now I need to find the prime factorization between 7 and 9. Actually, I need to find the lowest common multiple, sorry, between 7 and 9. 7, 9, 7 is just 7, 9 is just 3 times 3. And so in this case, my lowest common multiple is the multiplication of all of them together, which is just 3 times 7, which is just 63. Nice. Okay. So we have 25 over 7. We have 48 over 9. And now I need to get my denominator to 63. Here we're going to multiply it by 9. Top and bottom. Here we're going to multiply by 7. Top and bottom. Okay. 25 times 4 is 100. Okay? Therefore, 25 times 8 would be 200, because it's double what 25 times 4 was. Adding another 25, I'll get 225 over 63. You could also just work it out by hand, but you'll get 225 over 63. And then over here, we have 48 times 7. And for that, I'm going to work it out by hand because that looks painful. So 48 times 7. 8 times 7 is 56. Carry the 5. 4 times 7 is 28. Add the 5 back. We're going to get 336. Yeah. It's 336, right? So double checking my math here, because 48 times 7, we get 56. 4 times 7 is 28. Yep. Nice. 336 over 63. Those are some really nasty numbers to work with. Okay, so now we just have to add these all together. We have 225 plus 336. 5, wow, this takes me way back. 5 plus 6 is 1, carry the 1. 2 plus 3 is 5. 6. 2 plus 3 is 561. Yep. So we're going to get 561 over 63. Okay. Now all we have to do is find the mixed number of this, because you don't want to leave things in improper fraction if you don't have to. So we will divide this out. So 63 goes into 561 how many times? Let's see, 63 times 10 is 630. I don't think 63 times 9 is going to work, but I think 63 times 8 will work. So that's 4, that's a 2. 8 times 6 gets me to 48, that's 504. Yeah, if we added another 63, it would be just a few over, so I'm going to have 8. I'm going to get 504 here. I'm going to subtract this now. This is going to become a 5. This is going to become an 11. 11 minus 4 is 7. We'll be left with 57. And so we will have, hang on a moment, what was my original number? 561 over 63. So we have 561 over 63, or we have 8 and 57 over 63. Now, 57 over 63, there's a factor of 3 in there, and I can be left with 8. This number is 19 on top, and 21 is on the bottom. There you go. Okay, that was addition. We still have all of subtraction to do. So let's go ahead and do some subtraction examples. Okay, so for subtraction, we'll start off simple and then they'll get progressively harder. We'll start off with 13 over 17 minus 9 over 17. And since they have the same denominator, we just subtract the numerators. 13 minus 9 is 4. 17 remains the same. And there's our answer. Okay. Next problem we have is 23 over 46 minus 9 over 46. Since they both have 46 in the denominator, 23 minus 9, that is 14 over 46. Now, I know that both of these numbers are even, which means they have a factor of 2. And then after that, we're going to be left with a 7 and a 23. And those are both prime. And so your answer is 7 over 23. Okay. Here's the first part where they get a little bit more challenging. We're going to have 7 over 9 minus 3/4. And so we need to get a common denominator, lowest common multiple between 9 and 4, which in this case, we have 9 is 3 times 3. 4 is 2 times 2. And so since they have nothing in common, it's the multiplication of all of their factors, which is 2 times 2 times 3 times 3, which gets it to be 36. Now I'm going to do a little bit of a quicker math. I know, what should I multiply 9 by to get to 36? That'll be 4. And then what should I multiply 4 by to get to 36? I know that'll be 9. So I'm going to then do 7 times 4 and 3 times 9. So on the bottom down here, I'm going to have 7 times 4 is going to be 28. I'm going to have 36 on the bottom. And then 3 times 9 is going to be 27. And 36 is on the bottom. And so 28 minus 27 is 1 over 36. There we go. Okay. The fourth problem now. We have 8 over 21 minus 6 over 28. Now, here we can find the factorization of 21 to be 3 times 7. And the factorization of 28 is 2 times 2 times 7. And so I know both of these numbers have a 7 in common. So I'm only going to take one 7. I'm going to take the 2's from 28. I'm going to take the 3 from 21. And so my lowest common multiple in this case, whoops, wrong color, is going to be 7 times 3 times 2 times 2. Any order works. 2 times 2 is 4. 4 times 3 is 12. 12 times 7 is 84. And so now we're going to have 8 over 21 minus 6 over 28 84 now. We need to figure out what do we multiply this by to get to 84, what do we multiply this by to get to 84. This number is 4. This number is 4, and I'm going to be left with 32. This number is, that was 28, so I need to multiply it by 3. I'm going to get 18. It's not every time you see 28 multiplying to 84. 28 times 3, yes, is 84. And so now I'm going to be left with 32 over 84 minus 18 over 84. And I'm going to be left with what exactly on the top? That'll be 14 over 84. And then I can factor out a multiple of 2 here, and I'll have 7 over 42. Now, for the keen of you, for the keen-eyed of you, you may have noticed at the very beginning here that 6 over 28 is even. And it is even, and you actually could factor out a 2 here. So you could say that 6 is 2 times 3, and that 28 is 2 times 14. Factor that out, and you'll have 3 over 14, which may make your multiplication easier, and all of your work here easier. And it does make it easier. But just because we have it available to us, in this case, because it's rather straightforward, doesn't mean we'll always see it. And so sometimes you're going to be left with dealing with large numbers. And then at the very end, you can see that you can simplify, and then you can work down to a smaller number. Okay, we have 2 more problems to go through. We have 2 and 5/7 minus 1 and 1/3. Now I'm going to do this a little quicker because we've done quite a few examples of this, but I think you know how to do conversions from mixed numbers to improper fractions now. 7 times 2 is 14, carrying the 5, I'm going to get 19 over 7. And then 3 times 1 is 3, plus the 1 is 4, so I'm going to get 4/3. Awesome. Now, here, I need to get my lowest common multiple. 7 and 3 are both prime, so in this case, my LCM is just the multiplication of them, which is 7 times 3, which is 21. Alright, now, for some of you that may have noticed, you can say, well, what should I multiply 7 by to get to 21? What should I multiply 3 by to get to 21? The answer here is 3. The answer here is 7. And so, for my denominator, I'm going to be left with 21. For the first fraction, 19 times 3 is 57. And then 4 times 7 is 28. And so now, 57 minus 28, well, 57 minus 20 gets me to be 37. And then 37 minus 8 is 29. So I'm left with 29 over 21, which can simplify down to 1 and 8 over 21. Okay. Very last problem. Just gonna go down to a new page anyways. Alright, 13 and 3/9 minus 8 and 2/15. Okay, I'm going to do this a little quick. 9 times 13 is 91. Actually, sorry, no it is not. That is... 13 times 10 is 130. Subtracting 13 gets me 117, plus 3 gets me 120. That's what happens when you do things quickly. I was thinking 13 times 7 is 91. 13 times 9 is 117. 8 times 15, I know 15 times 10 is 150, so then I just need to subtract 130 and I'll get 122 over 15. Okay. Now I need to get my lowest common multiple here. I'm going to leave you to figure this one out, but my lowest common multiple is going to be 3 times 3 times 5, which is going to be 45. So then here I'm going to multiply this by 5, multiply this by 3. And so 120 times 5 is going to be 600. I'm just going to write that down here at the bottom. 122 times 3 is going to be 366. And then obviously my denominators in this case are going to be 45. And so now we can subtract. Well, 600 minus 370, sorry, 600 minus 360 would be 240. Then if you subtract 6 more, gets you 234 over 45. And then simplifying this out, let's see, 45 times 4 is 180, so 45 times 5 is 225, so I will have 234 minus 225 is 9 over 45. And then I will be left with 5 1/5. Nice. Wow. That was a lot of math that we just did. But luckily enough for us, that is the end of this video. I hope this helped. This is some examples of just adding, subtracting, multiplying, and dividing fractions. I feel like when it comes to math, practice makes perfect. The more practice you do, the better you get at it. Hopefully this will help you understanding lowest common multiple. The more you do of it, the easier it is for you. The more you take the reciprocal, the easier it gets. And the more you work with fractions, just the better math sense you have. But like I said, that is the end of this video.